All right, AP Stats. Now the first time you get to hear my voice. Jokes of the day, you can hear that from me personally. You don't need it here. But if you want one, I'll put one in at the end. A little suspense. Stick through it. 8.3, calculating the confidence interval for a mean difference. That means matched pairs. So, matched pairs, if you remember from what we did earlier in the year, you have to understand that we are going to be looking at a placebo and someone who's getting treatment. So, in this case, two seeds of the same type of plant are planted in the same pot. One is randomly selected, treated with new fertilizer. The other one's the control group. We want to estimate the mean difference in growth for 10 such pairs of plants. A school teacher uses matched pans where she gives a pre-test and a post-test, determining if the students improved. And finally, a study tries to determine whether caffeine addicts are more depressed when they receive a caffeine placebo rather than a caffeine pill. So, what makes an experimental design? So in order to have an experimental design, each person, and again, if you hear this noise, it's just my pen. Each person receives both treatments. You guys love my handwriting. Or each treatment is given to one subject in each pair. All right, I'll change colors now, guys. How do you analyze a matched pair data set? Well, you have to apply the one sample T procedures, which we'll talk about again. To the observed differences. Meaning, what changed from the one to the other? It doesn't matter which direction you go, as long as you explain that, in the pairs or treatments. So again, hopefully you can do both. You give somebody one, and then you give them the other, and you check it. Okay. So, this one here, we're going to talk about the caffeine. Each subject was barred from coffee, cola, anything with caffeine. Instead, they took capsules with caffeine. During a different time period, they got a placebo. The order was randomized. One of the tests given to the subject was depression. The subject was depression, scored by an inventor. Higher score means more depression. So construct 90% confidence change in depression score. So what you need to know here is that you're looking for the difference. I'm going to make up a column over here, and I'm going to do placebo minus real caffeine. I'm doing placebo minus real caffeine. So I'm going to subtract each one, and you're going to get 11, 18, 1, 4. Now where am I getting 11 and 18 from? 16 minus 5. 23 minus 5. Okay. 6, 19, and they're all not going to match up because of the size of my pen strokes, but 6, 3, 13. Finally, 1 and negative 1. All right, now why is there a negative 1? Because 0 minus 1 gives me negative 1. All right, check your conditions. Number 1, random. Do you see the word random? Well, I already said it was randomized, right? So we met number 1. Number 2, independent. Is the population greater than or equal to 10 times your sample size? Well, in this case, my sample size is 11. We can assume that there's more than 110 people. So now we're going to go on to, so we're going to go to use our standard deviation of the population. And finally, is it normal? Well, I don't see normal. It's not greater than 30. So I have to check for skewness or outliers. So I can either put it all in my computer and then do a box and whisker, or I could just list them out. Now I'm going to do this here and do the box plot. Sorry, a stem and leaf plot, but I'm going to do a double one so that I could do, and I also need -0, 1, and 1. So in this case, I have -1. I have a 1, a 3, and a 4. I have a 6 and a 6, and I have an 11, 13, 18, 19. Now, if I look at this, I have a little bit of a tail, but not a huge skewness. So I'm going to say, in this case, it's okay to assume the T procedure. There's some skewness, but I don't see any outliers. Okay. All right, so I got to do the calculations. In my calculator, I'm going to go to Stat Calc, 1-bar stats. I'm putting all this in. So I put all this stuff in my calculator, and I just kind of checked out what the heck was going on. All right, so what came out was that the average was a positive 7.364. The standard deviation for the sample was 6.9177. Okay, so what I then did at this point is I had to take my situation of a formula saying the average plus or minus a t-score, and my t-score times the standard deviation divided by the square root of it. So you can plug your numbers in. How do I get a t-score? Inverse t. Well, I have a 90% confidence interval. That means 1 minus 0.9 divided by 2, which is 10.05. So inverse t of 0.05, comma, degrees of freedom. Well, if there's 11 people, I use 10 as my degrees of freedom. That's going to give me a t-score of, I believe, around 1.812. I'm running out of room here. Mine is bigger on the screen, and then times 6.9177 over the square root of 11. All right. Anyway, you put all that in, you get two answers of, my two answers are 3.584 and 11.143. Okay. And finally, I'm going to say we are 90% confident that the mean difference, not that the mean, but the mean difference, or the change, or from placebo to caffeine. Well, in this case, I'm going to write placebo minus caffeine. Okay? For all, whatever they called these people diagnosed as caffeine dependent. I don't know. For all caffeine addicts, we'll call them, is between whatever I just came up with. And in this case, it's between 3.584 and 11.143. Okay, so that's how you want to do this. You have to make sure that you find these numbers on the side, which are your difference, and then from there you follow the same as what you did as if it was a regular t. So you have to use inverse t. If they give you a confidence interval, again, you have to subtract and divide by 2. All right, so I'm going to have you guys try one in class. Hopefully this is good. And I hope everybody got my last joke, but here's another one. I have a Russian friend who's a sound technician, and I have a check 1 2 and a check 1 2. Anybody get the joke? I have a Russian sound technician friend, and a check 1 2 and a check 1 2.